Question number 8. Simplify the ratios and leave your answers as simplified fractions. That means, class, do not convert them to decimals. Simplify the fraction as far as you can and leave it in fraction form. The first two problems here are just ratios that we have to simplify. You're going to have to figure out what number goes into both the numerator and denominator. I can see here that looks like both of those numbers will allow 9 to go into them. 54 divided by 9 is 6. 18 divided by 9 is 2. And it looks like I can divide them again by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. We have gotten to our most simplified form. Let's take a look at next one, 10 over 24. Well, I can tell both of those numbers are even, so I know 2 goes into both of those. 10 divided by 2 is 5. 24 divided by 2 is 12. And 5 is a prime number, so we cannot simplify anymore. So we've got 5 over 12. The next two problems have different units of measure in the numerator and denominator. The question gives me the relationship between those two units of measure. So I'm going to go ahead and create another fraction that I know is going to equal to 1, so it's not going to change our answer. I know 12 inches and 1 foot are equal to each other. I'm going to put feet on top because I want to cancel feet on bottom. And then I know that 1 foot is equivalent to 12 inches. So now all we have to do, class, is multiply across. You can see right now that the feet on bottom will cancel feet on top. Inches on top will cancel inches on bottom. All we have is 38 times 2, which is 38. That's the numerator. 2 times 12 is 24. That's the denominator. And let's go ahead and simplify this. Looks like both of these numbers are divisible by 2. They're both even. 38 divided by 2 is 19. 24 divided by 2 is 12. 19 is prime, so we can't go any further than that. There is our simplified ratio without any units of measure. Last one, 12 pounds over 72 ounces. It looks, class, like I actually made a typo here. It is not ounces, so let's get rid of that H. And let's make it 72 ounces. So we're going to go ahead and multiply this by a conversion ratio. And it's going to be equal to 1, so it's not going to change our answer. Ounces are on bottom, so ounces, let's put an O here. Ounces are on top. Pounds are on top here, so they're on bottom here. And we see that 16 ounces are equal to 1 pound, so that's equal to 1. That's the numerator and denominator. They're both equal to the same thing. Let's multiply across. So we've got 12 times 16 is 192. 72 times 1 is just 72. I can see both of those numbers are even, so I can definitely divide by 2. 192, I need more room here, hang on a sec. 192 divided by 2 is 96. 72 divided by 2 is 36. Looks like I've also got even numbers here, but I also can check my calculator, which I've already done, and I can see that 6 goes into both of these numbers. If you would have chosen 2, that's okay, you'll get there eventually. 96 divided by 6 is 16. 36 divided by 6 is 6. Again, these are both even numbers, so I can divide them by 2. 16 divided by 2 is 8. 6 divided by 2 is 3. 3 is prime. That's as far as we can go. Now, you know what, class? Let's make sure you're not getting confused. These are not exponents. These are divisors. We're dividing by each of these values. Let's go ahead and circle all of them so you can see. We're just using that, just my way of writing down what number goes into both the numerator and denominator. And that is the end of question number 8. You've seen that lots before. Hopefully you're doing okay with those. Number 9, find the value of the variable. Well, we're going to cross multiply. 4 times 30 is 120. 120 equals 12x. Divide both sides by 12, and you're going to get exactly x equals 10. There's our first answer. Cross multiply again. 15 times 30 is 450 is going to equal 2x. Divide both sides by 2, and you get x equals 225. All right, now I've got some binomials. No big deal. We've done these before. 8 is going to be multiplied by y plus 3. 18 times 3 is 54. Let's distribute. 8 times y is 8y. 8 times 3 is positive 24 equals 54. Algebra 1. Subtract 24 from both sides, and we end up with 8y equals 30. Divide both sides by 8, and you're going to end up with y is approximately, oh sorry, this actually comes out to exactly 2 decimal places. Let's just leave it that way. Y is equal to exactly 3.75. And the last one. Y plus 8 times 6, I'm going to write it my normal way to distribute. 6 times y plus 8 equals 9 times 4, which is 36. Let's distribute. 6y plus 48 equals 36. Now, when we subtract 48 from both sides, class, you're going to end up with 6y equals negative 12. That's okay. Y can be a negative value and still make this a valid proportion. Divide both sides by 6, and you have y equals negative 2. Take a look at that, what that does up here. 6 over 9 is equal to 4 over negative 2 plus 8 is 6. So 6 over 9 is equal to 4 over 6. And by the way, if you ever want to check your answer, just go ahead and plug your x value or your y value into your equation and see if both sides of the proportion are true. If you got your answer right, it will be true. That's the end of question number 9. All right, we're up to question number 10. Question number 10. Using the transformations below, what would be the transformed coordinate of negative 7, 12? So it looks like they want to have us plug that into our transformation notation and come out with our new coordinate. Let's do the first one. Well, using the transformation notation in A, that means negative 7, 12 is going to change to, let's take a look. Our x value is moving to our second position in our coordinate, and the sign is staying the same. So negative 7 is moving over to here. Our y value is moving to the x position, and the sign is flipping. Y was 12, so now it is negative 12. There's our first one. Okay, next, every one of these class, just for practice, they all start off with the same coordinate. So negative 7, 12, let's take a look. X stays the same and stays in the same position, no sign change. Y just flips sign, so 12 becomes negative 12. Letter C, let's go through this transformation notation. X moves to the second position from x to the y position, and the sign flips. So negative 7 moves to the end of our coordinate, and the sign flips. Y moves to the front of our new coordinate, or the x position, and our sign stays the same. So that's just 12. So 12, 7. You know, let's take a look at this. And I might have made a mistake here. The x value moved to the y position. Oh, and the sign flips. So that should have been negative 7. All right, we got the last one here. Start off with negative 7, 12, just like the other ones. And the x stays in the same position, but the sign flips. That changes to positive 7. The y value stays in the y position, and it doesn't change at all. So 7, 12. There are our 4 practices for transformation notation. Question number 11. Is a scale factor of 5 over 4 a reduction or an enlargement? Class, we have learned that a scale factor greater than 1 is an enlargement. So I'm going to go ahead and write here, scale factor is greater than 1. So I'm going to go ahead and write on my sentence answer. Since 5/4 is greater than 1. You actually, no, I'll write it out for you. Is greater, oh goodness, it'll take me a little longer. Greater than 1. It is an enlargement. Afraid I'm not going to fit this. I'm going to try to fit it. There we go. Since 5/4 is greater than 1, it is an enlargement. Let's take a look at number 12. Number 12 says, is a scale factor of 1/6 a reduction or an enlargement? Well, that is a scale factor that is less than 1. So, since 1/6 is less than 1, it is a reduction. Now class, if you're having a hard time seeing that 5/4 is greater than 1, just plug it in your calculator. 5 divided by 4, and you see that is definitely greater than 1. For the next one, 1/6, you just do 1 divided by 6, and you'll see that turns to be a decimal that is clearly less than 1. So if you have a hard time seeing that those numbers are greater or less than 1, just divide them out in your calculator, and you will see that clearly they are greater than and or less than 1. Let's take a look at number 13. Number 13. Label the pre-image and image, then write the scale factor as a simplified fraction. That means don't change it to a decimal. All right, let's do the first one. P does not have prime. That is our pre-image. The copy is the prime. That is the image. We know scale factor is always image over pre-image. Our distance to our image is 8. Our distance to our pre-image is 24. Both of these can be reduced by, looks like by 8. So we can divide both of these by, that's pretty small, let's try a little bigger. I can divide both top and bottom by 8. I still can't read that. Let's try it one more time. Divide top and bottom by 8. And we end up with 8 divided by 8 is 1. 24 divided by 8 is 3. Makes sense? This is clearly a reduction. So our scale factor is going to be less than 1. Take a look at the next one. P has no prime. That's our pre-image. Our prime is our image. Scale factor is always image over pre-image. Whoa, I don't know what happened there. Image over pre-image. The distance to our image is 16. The distance to our pre-image is 6. These are both divisible by 2. So 16 divided by 2 is 8. 6 divided by 2 is 3. That can't be reduced anymore because 3 is prime. So our scale factor there is 8/3. This is clearly an enlargement. So we better have a scale factor greater than 1, and we do.